So what I see over here in the first diagram is 3/4 of a pizza, and this is one whole apple with half of an apple. I can write it as 1.5 apple. We have 100 rupee note, and this is time, which shows it is 111, and I'm going to write this as 1/11. Okay, so let's think about all of the numbers that we see on the screen, right? If you have to categorize these numbers, what would come to your mind? You could say fractions, you could say whole numbers, and all of these numbers that are a part of our daily life, you see them all around you, are known as rational numbers. So, rational numbers can be expressed in different forms, but essentially, these are the numbers that can be written in the form of P upon Q. So, in the case of the pizza, we have a fraction, and over here with the apples, we have a mixed fraction, right? Now, what we're going to see is like all of these fractions, how can they be converted into decimals? And we're going to go one by one. So let's think about the case of the pizza and the apples first. So I'm going to write it over here, 3/4. And I want to convert it into a decimal. So I'm going to divide like this. 3 becomes our dividend, 4 becomes a divisor. And because 3 is smaller than 4, I'm going to take help of a decimal, which will enable me to put a 0. 4 times 7 will give me 28. I subtract 30 and 28, I get 2. Again, because of the decimal, I can put another 0. And then 4 times 5 gives me 20 and goes in completely. What I do have is the decimal expansion of the rational number 3/4, which is 0.75. Now let's take a moment to look at 0.75 and what sort of a decimal expansion is that. What we do see that this is a terminating decimal expansion. That means that it is fixed, it terminates, it is finite. So some rational numbers, when they're converted into decimals, they result in expansions that are finite and they terminate. Let's also quickly think about the case of apples. So we have 1.5 apples, and first of all, this is a mixed number, right? So we need to think of converting it into a fraction, which would be an improper fraction with the numerator being bigger than the denominator. And then we're going to go for division like we did in the case of 3/4. So in order to convert a mixed fraction into an improper fraction, we are going to multiply 2 with 1, and then we're going to add the 1 in the numerator. So our denominator is 2. 2 times 1 is 1. 1 plus 1, we get 3/2. So like you see over here, the numerator is bigger than the denominator, which makes it an improper fraction. But what we are interested in is the decimal expansion of this fraction, right? So we are going to get started with the division. 3 becomes the dividend, 2 becomes the divisor. 2 times 1, we get 2. And then we put a decimal and we get 2 times 5 is 10, goes in completely. And as a result, 1.5 is equal to 1.5 as a decimal. And again, this expansion is terminating and finite. So now let's think about 1/11. And 1/11 is a rational number, but we are going to divide the numerator by the denominator to check what sort of a decimal expansion does this result in. So beginning our division process, so there's 1 as the dividend and 11 as the divisor. We're going to take the help of a decimal and add a 0 over here, which again is smaller than 11. And therefore, we're going to insert another 0 over here. so that we can make this 100, and then 11 times 9 will give us 99, and that would get us 1. Now again you'll see that we'll have to put an extra 0 in addition to the 1 that we can put, and therefore we insert a 0 over here and go on with the process. Now what do we have over here? We see that we are doing this again and again, and therefore, this process, if we keep on dividing like this, will go on. And what we can say about the decimal expansion of 1 upon 11 is that it is non-terminating. That means it is not finite, it is infinite, but it is repeating. So the digits are repeating itself after the interval of 2. So we have 0.090909. And this is the second type of the decimal expansion that rational numbers have. So there are two, right? So rational numbers have, when they are converted into decimal, they have two types of expansion. One is terminating